Okay, so this first question is all about density. So we've got a rock here, piece of limestone it says. The student was not able to calculate a volume of a piece of limestone using measurements taken with a ruler. Why can't they use a ruler to work out the volume of this rock? What do you guys think? Let me get my website up whilst you guys tell me the answers. If you know it, this topic's under density, it's under particle model of the matter. Remember, this whole website's free, guys, if you want to check it out after the live. Second one, so yeah, most people are saying it. It's the second one because basically it's an irregular shape. So here we've got a calculation with a regular shape, which is a cube, but in the question, we've got a rock. A rock doesn't have a regular shape. It's not cubic. You can't work it out by using a ruler. You'll need to work it out using another method, which I'll go through in a second because that's the next question. So it's because the piece of limestone is an irregular shape. Well done, guys. B, okay, straight in with a 4 marker next. So we've got some equipment, limestone, so that's what we're going to try to find the volume of. We've got a displacement can. You might know this as a Eureka can. Measuring cylinders and a beaker, and it's asking us to determine the volume. It's not asking us for the whole practical. So this whole thing is a required practical. It's basically a practical where you need to work out the density of something. This is only asking half of the method. It's only asking you to work out the volume of a rock. How can you work out the volume of an irregular shape like limestone? How can you use this displacement can? Any ideas? This is both triple and combined, so it's useful for everyone. This is paper 1. So I'll show you on my website what topic it comes under. It comes under particle model of the matter. Density comes under the required practical for density. Okay, thank you. Mazin says, fill the water until the spout, then place the rock inside. Good. So basically, let me explain. So what you need to do, so here we've got the Eureka can, okay? So the Eureka can is unique. It's not like any old can. It's got a spout on it. So if you fill water past this level, the water is going to flow out of the spout, okay? So what you do is you fill it up to that point, up to the point where it's starting to flow, and then you add your object. So in this case, you would be adding your rock into it. So once you put the rock into it, it's going to cause this water level to rise and the water is going to flow out. And then you collect all the water that's flowing out into a measuring cylinder and you measure it, and that would give you the volume. So that's basically what we're trying to explain here. We want to explain it in 4 marks. Let's see what everyone's saying. Yep, so you place the rock inside. Yep, this is the density practical, exactly. So let's try and get 4 marks here. First thing you can say, just say add water to the displacement can. They've called it the displacement can. You can call it a Eureka can as well, if you want. Up to the spout. Because at that point, you know it's full. Then, good, everyone's saying the answer here. Place the limestone in. Then you can say collect the displaced water. And then for the 4th mark, collect the displaced water using the measuring cylinder. And then whatever volume you get on the measuring cylinder, that's the volume of the rock. Hope that makes sense. Let me know if there's any questions here. Yep, good. Good to hear I'm helping out, guys. Up to start. Yep. Lovely. Okay, so we've just worked out the volume. So this next part, this is the next part of the practical. Remember, the whole aim is to work out density. So what you do after that is you use the volume you got. So what they've said here in this question is the volume is 62 centimeters cubed. So they've done this experiment and they found that it was 62 centimeters cubed. And then they used a mass balance, because that's what you need for this practical. You also need a mass balance because you need to weigh the mass of the rock. So once you've got the volume from the Eureka can, the mass from the mass balance, you can use the density equation, density is equal to mass over volume, to work out what the density is. That's what it says all here, that's what it explains. So they got a mass of 155 grams. So you can just do mass over volume. So that's 155 divided by 62. Anyone got the answer? Maria's got 2.5. That is absolutely right. 2.5 grams per centimeters cubed. Excellent, guys. Okay, on to the next question. Density can be measured in grams per centimeters cubed. There's another unit for density here. What do you guys think is the other unit for density? Let's remind ourselves of the equation for density. Density equals mass over volume. So Sophia said second one. Did the rest of you agree with that? So Sophia's saying second one. Any other answers? Yep, another one. Someone else, I'll be saying that as well. Good, good, good. So basically what you want is a unit for mass at the top and a unit for volume underneath. Centimeters per gram cubed is not even a unit, so that doesn't count. Kilogram cubed, that's not even a thing. Kilogram cubed is not a thing. Mass over volume, we got kilogram, which is a mass. We got volume, which is meters cubed. So it's kilograms over meters cubed. Well done, guys. Where do I get these papers from? Get it from my website, flashrevisionlab.co.uk. So I've got all the ones that I've gone through in my lives here. You can just download them. Just press paper download. You can try all my past ones, and you can watch the replays on YouTube as well. To do that if you wanna try a few more. Okay, next one. Do I go live every day? No, I go live every Wednesdays and Sundays. Thank you. Okay, next one. Draw a bar on figure 3 to show the density of the unknown type of rock. It says here it's 2.4 grams per centimeters cubed. So we need to find 2.4 here. So let's look at the scale here. Let's zoom into that. 2.4 is going to be around here, isn't it? It's going up in 0.1s. So you basically want to go one square below this 2.5 line. So I'd say it's around here somewhere. And obviously use a ruler when you're doing this in your actual exams. So that's what that would look like. Let's just shade that in. So that's the unknown rock they've asked you to do. Complete the sentence. The data in figure 3 suggests that the unknown type of rock is, what would you guys say that is then? Unknown type of rock. Well, I'll shade this in a bit better. You'd say it's obsidian. Yep, exactly. It's the same level as obsidian. The answer is going to be obsidian. These first questions are a bit more straightforward. The harder questions will come at the end of the paper, guys. I always start off the papers quite easy. Well, hopefully it's easy for you guys when I explain it. So yeah, obsidian. The student cannot be certain that the unknown type of rock is one of the types of rock in figure 3. Explain why. Give a reason why. So basically what this question is saying is, yes, it could be obsidian because it's got the same density, but we can't be 100% sure that it's obsidian. What do you guys think? Why can we not be 100% sure that it's obsidian? Any answers? Yep, because there could be other types of rocks. Here we only look at 4 types of rocks. There's so many other types of rocks around there. It could be one of those. Another type of rock could have the same density as obsidian. So it's not 100% guaranteed that this is obsidian. So you just need to say, because other types of rocks could also have the same density. That makes sense. Okay, next one. We've got a rock here that has holes in it. The holes contain air. Okay, this is important here. Which diagram shows the arrangement of particles in an air? So air is a gas. Which of these? 4th one, exactly. These 2 are probably solids because they're arranged regularly. This is probably a liquid. Must be the last one. That's a gas there. Well done. Next question. The holes containing gas causes the density to be something the density of the other types of rock. What do you guys think? The holes in the air. The holes containing air. What's that going to do to the density of the rock? So imagine you've got a rock, piece of rock here. It's got a certain density, but then you add holes in it. What's that going to do to the density of the rock? Is it going to increase it? Is it going to decrease it? Or is it going to keep it the same? There we go. Everyone's saying the right answer. Well done, guys. Less than, yep. Good stuff. All right, that's first question done. Questions are getting harder now. So this question is on energy. Let me get the notes on energy up on my website. So that's topic 1 in physics. So let's go to energy stores and systems. Okay, so I'm just gonna have the different energy stores up here. So these are the 8 energy stores you need to be aware of. Okay, so keep that in mind. So in a sport called far leaping, an athlete uses a long pole to cross a river. So you can see that. This person is climbing on the pole, or they're using the pole to jump over the gap. Different stages are labeled as A, B, C, D, and E. First question. Between positions A and B, the athlete speeds up. There is an increase in what? Which type of energy would you say that is? The key thing here is the person is speeding up. Exactly. It's going to be kinetic. Kinetic energy. So out of all the 8 types of energy, kinetic is the energy of moving objects. The equation for kinetic energy is half mv squared. So if you have a higher speed, that means your kinetic energy is going to be higher. So the answer is going to be kinetic. And a decrease in the athlete's what store of energy? What do you guys think what type of energy do you think is going to decrease out of these? That's a bit trickier. We've used kinetic already. Let's see what everyone's saying. Someone's saying gravitational, someone's saying chemical, loads of people saying chemical. Yes, it is chemical. Well done, guys. It's chemical because chemical is all to do with energy that's being released from a reaction. So any food that's been eaten is going to be chemical energy. So a person has chemical energy. That's where we get our energy from. It's from the food that we eat. You can also say batteries if you've got anything electrical powered. That is also chemical energy in the batteries. So it'll be a decrease in the athlete's chemical energy. Well done. Yeah, chemical energy is energy from releasing bonds. So you basically get it from any reaction, pretty much. Any reaction that releases energy or has the potential to release energy would be chemical. Next question. Between positions B and C, the athlete jumps to the pole and climbs up it. Which statement describes the change in the athlete's energy between points C and D? Let me show you points. Which one was it? B and C. from there to there. What's changing here? Everyone is saying the last one. Gravitational potential energy increases. That is absolutely right. Yeah, that's because gravitational potential energy is all to do with height. Energy stored due to an object's height in a gravitational field. The higher up you are, the greater the gravitational potential energy you have. Excellent. Next question. The pole falls over from position C. The athlete lets go of the pole and lands on position D. And we've been given the change in height, the mass, and the gravitational potential energy. They've been nice in this question and they've given you the equation in the question. You don't need to look it up in the equation sheet. So all you need to do is plug these numbers into the equation now. So mass times gravitational field strength times change in height. If anyone's got a calculator, can you work that out, please? Yes. So that's going to be mass, which is 50 kilograms, times 9.8, which is the gravitational field strength, times by 3. And that gives an answer of, yeah, thank you very much, 1,470. 1,470 joules. Well done, guys. Okay, I think that's question 2 done. Oh no, still got one more in question 2. Oh, no, we got more. Okay. Kinetic energy of the athlete at position D is 1,600 joules. The mass is 50 kilograms. Still calculate the speed. So again, they've been nice. They've given you the rearranged version of the equation. But let me show you how to rearrange it, because most of the time they ask you to rearrange the kinetic energy equation. Okay, so you know it's kinetic energy because they've told you here. They've given us energy, they've given us mass, and they want us to work out speed. Okay, so the equation for kinetic energy is half mv squared. Okay, half times mass times speed squared. So what we're going to do, I'm just going to rearrange this so you guys know how to rearrange it. So kinetic energy is equal to half times m times v squared. Let's get rid of the half first. So what we'll do is we'll times both sides by 2. So that's going to make it 2 times kinetic energy is equal to mv squared. So we've removed the half now. Now we can move the m across. This is m times v squared right now. If we want to move it to the other side, we need to divide both sides by m. Divide both sides by m. So that's going to make it 2 times kinetic energy over m. All of that is equal to v squared. Now, we don't want v squared, we just want speed on its own. So square root both sides. Square root that side, and let's square root this side. So it's going to be square root 2 times kinetic energy over m, which gives you v, which is exactly what they've given us here. So the reason I'm doing this, guys, is just so you guys know how to rearrange this, because in most exams they don't rearrange it for you, they expect you to do it. So that's how to rearrange it. They've been nice in this question and they've rearranged it for you. So all we need to do now is put the numbers in. Let me know if you do have an answer. Anyone got an answer yet? Yeah, it looks like people are getting the answer. Good. So it's going to be 2 times kinetic energy, which is 1,600 joules, divided by the mass, which is 50. And then we can square root that. So people are saying 8. Yes, the answer is 8. And then the units for speed is meters per second. The final answer is 8 meters per second. Okay, any questions on that? Yeah, so you can either learn to rearrange that, or you can just memorize this. Either way is fine. Whatever's easier for you. Next, figure 2 is repeated below. Okay, so they've done it again. They've shown us the diagram. At position A and E, the athlete is standing still. Okay, so see here, standing still here, they're standing still here. Why does the athlete have less energy here? So they have less energy here compared to here, even though they're standing still at both positions. What would the answer be here? So GCSE 2024 saying C, because the height of the athlete above the water has increased. No, it hasn't. Look, they're both at the same level. Oh, it has slightly. Number one, so we got people saying number one, number two. Less position. No, because if they're slightly higher up, so you can see here they're slightly higher up, that would mean they're higher in gravitational potential energy, doesn't it? Because gravitational potential energy depends on height. The question's asking, why is it less? It's because some of the energy that they've used to jump from here to here, some of that chemical energy that this person has had in their body has been used up. It's been used up to basically move the air out the way or to heat the air up. So what's happened is the energy, because they've basically used up the food that they've been eating to allow them to jump like this. So that energy has been dissipated. We say that's the word that we use. It's been dissipated into the air. So we say the answer is A. This is combined and triple. Everyone needs to know this stuff. Hope that makes sense. It's a bit confusing because it looks like it's increased because this person's higher up, but it's asking why they have less energy. And that's because they've used it on jumping. They've used their chemical energy on jumping, and that energy has been dissipated into the air. Yeah, so basically it could be heat. It could be heat energy, yeah, or it could just be kinetic energy of the air particles. Because when you're running through air, you're basically moving the air out of the way, isn't it? So it could be transferred that way as well. No problem. Next question. Athletes have a large power output when they are far leaping. What is meant by the power of an athlete? Definition of power. Let me get that up in the notes. Here we go. Power. Power is the rate at which energy is being transferred or work is being done. The rate at which the athlete transfers energy. Well done. I do teach A-level subjects, but just not on TikTok. This is just, I just do this for GCSE students. Sorry. Next question. A second athlete crossed the same river by far leaping. They had less power than the first athlete when running between positions A and position B. Complete the sentence. Two factors that could explain why the second athlete had less power than the first athlete are the time taken by the second athlete to run between positions A and B was something the first athlete. Second one, the work done by the second athlete was something the first athlete. What do you guys think these words are? First. People saying less. First of all, tell me what you think number one is. What do you guys think number one is? And I'll explain it. More. People saying more. Okay, so to work this out, it's useful to use the equation for power. So let me show you. Equation for power. Here we go. Power equals work done over time, or power is equal to energy transferred over time. They both mean the same thing. Work done and energy transfer, just think of them as the same thing. The question is saying the time taken is basically asking what's happened to the time taken. The first athlete has less power. So if you want less power, what do you need to do to time? Look at this equation carefully. What do you need to do to time to decrease power? You got a number here. You want to divide it by another number. If you want a lower power, you need it to be, well done. You need this number to be more. At the bottom of a fraction, if you have a bigger number at the bottom of a fraction, it's going to make the total outcome smaller. So time has to be more than. The answer to the first one is more than. More than. Second one is to do with work done. So let's look at that equation again. Work done. What do you need to do to the top of that fraction to increase, to decrease power? What needs to happen to work done? Kind of common sense. It's a bit of maths in here. Yeah. You kind of need to know fractions. You need to understand fractions. So if you increase the top number, it's going to increase power. If you decrease the top number of a fraction, it's going to decrease the power. So you would want it to be less than. It's worded a bit awkwardly, so I can see why people would get this wrong. Hope that makes sense, guys. Let me carry on. Next question. So this one's all to do with circuits, it looks like. What's the correct symbol for a filament lamp? Which one do you guys think it is? A, B, or C? Write it down in the comments and I'll get the notes up while you do that. So let's go on to topic 2, electricity. This would come under circuit symbols. Here's all the circuit symbols you need to know. So we've got a mix of people saying B and C. Most people are saying B. Yeah. Filament lamp is B. Well done. These are all the circuit symbols you need to know. Answer is B. Next one. What is meant by an electric current? What do you guys think the answer for this is? A, B, C, or D? Definition of current. So we've got Samuel saying B. Any other answers? B. Yep, everyone's saying B. Answer's B. Don't say this. I know some people might say D because of the speed at which the charge moves. No, that's not the definition. Definition for current. Here we go. The flow of electrical charge. The flow of electric charge. Let's just double check that in the spec. Electric current is a flow of electrical charge. Yeah, that's what you should write down in your exams. This is combined and triple. All these questions are relevant for combined and triple. Okay, next question is asking us to draw a circuit. We've got an ammeter, a battery, and a variable resistor. A manufacturer connected an ammeter, battery, filament lamp, and a variable resistor in series. Draw a circuit circuit diagram to show the circuit. They haven't given me much room here. Let me draw it in this little space here. So, what do we need? We need a battery, all in series. What does in series mean? Can anyone tell me what series means? There's our battery, little plus symbol. Series means they're all on one loop. Well done. So we've also got a filament lamp. Let's add that in next. We've also got an ammeter and a variable resistor. Ammeter, remember this, ammeters need to be connected in series. They always need to be connected in the same loop as everything else. If it was asking us for a voltmeter, they need to be connected in parallel. And then we've got a variable resistor all in the same loop. Like that. That should be enough for the marks. But if it did ask for a voltmeter, I'll just show you what you would do. If it had asked for a voltmeter around the lamp, for example, you would just draw it like this. has to be in parallel. Voltmeters need to be in parallel. Okay, but let me get rid of that so you guys don't get confused. That's how to get all the marks for that question. Next question. How could the manufacturer increase the current in the filament lamp? What do you guys think you can do? They're trying to increase the current. So in order to increase current, let's look at what resistance means. Resistance is something that slows down the flow of current. The higher the resistance in a circuit, the lower the current. Okay? The higher the resistance in a circuit, the lower the current. So, how could the manufacturer increase the current? Yeah, so resistance, remember, more resistance. If resistance increases, it means current decreases. But the question is not asking to decrease current, it's asking to increase current. So we're doing the opposite. So to increase current, we want to decrease resistance. The answer is the second one. Let me know if there's any questions, guys. Okay, so we got a few calculations here. Let's see how much left we've got. Okay. So remember, you can download these questions on my website. If you just joined, go on to flashrevisionlab.co.uk. The one that we're going through right now is this one here, the 24th of April. And then I've got all my past ones here, where you can watch replays of that. When the potential difference across a filament lamp was 0.75 volts, the current in the filament lamp was 0.16 amps. Calculate the power. So we want the equation for power. Again, they've been nice and they've told you, but you'd probably just need to look it up in the equation sheet. People will get confused because there's other equations with V and I in them, with a potential difference in current in them. Don't use this because it's not asking us for resistance. This is the equation you're supposed to use. This is the equation in the formula booklet that you should use because it's asking us for power. So just times the two numbers together. What do we get? Let me know in the comments. 0.75 times 0.16. Yep, well done. That gives us an answer of 0.12. Well done. Okay. Part F, write down the equation. Okay. These questions are always good. Easy 1 marks. You just need to look this up in the formula booklet. What do you guys think? What's the equation that links Q, I, and T? So usually in the old papers, people would need to memorize these equations, but for the last few years since COVID, they've given you the equation sheets. So you just need to look it up. So equations are, Q equals IT. Let me give you every single electricity equation that they can ask you. So we've got V equals IR. We've got Q equals IT, which is what this question's all about. Okay, Q equals IT. What else we got? We got E is equal to Q times V. This is one that people always forget for some reason. And then we've got the power ones. P is equal to IV. And then we've got the tricky power one with the squared in it. P equals I squared R. And then power, I don't know how, I don't remember how they worded, which way around they did it. Maybe it might be energy is equal to power times time. And that should be all of them. Hope most of these look familiar to you guys. So do you think they won't ask these kinds of questions anymore? Yeah, so that's what I thought as well. I thought because they're giving you equation sheets, they won't ask you questions like this, but they have come up in the last 2 years for some reason. So yeah, it's just easy marks, guys. You just need to look it up in the equation sheet. So that'll be good if these come up. what percentage of P2 is worth physics 1 paper roughly? Is usually 1 or 2 questions, so maybe around like 25% maybe. It's quite a big topic. Electricity is quite a big topic. Which questions are most likely to turn up apart from equations? It's hard to... Calculations with equations, yeah, and it's hard to predict, but a lot of physics is calculation based. So it's not like biology and chemistry. There will be a lot of reciting equations and trying to use the equations. What do the equations stand for? So V is potential difference. So you can look, I've got them all on my website. Every single one that you need to look at. So V equals IR, and I've got the units for each of them and what each of them mean as well. So you can just look them all up. But yeah, V is potential difference. So real quick, potential difference. I is current, R is resistance, Q is charge, T is time, E is energy. Done that. P is power. Yeah, we've done that all. Okay, next one. Oh yeah, also, when they give you a question where they ask you to recite an equation, it usually means you need to use it in the next question. So it's kind of a clue. So if they've given you a question like this, it means in the next question, you probably need to use this equation. So see here, they've given you current, they've given you time. It's asking us to work out charge. So we need to obviously use the equation Q is equal to IT. What's one thing you need to remember before you do this calculation? Have you done the biology paper 1? So I'll go through biology paper 1 next week. Next week's live will be biology paper 1. Thank you. Yes, you need to sort out the units. Loads of people will get this wrong. Loads of people would forget to convert the units. On my website, I've got all the units for the equations as well. So if you look at the Q equals IT equation, where is it? Here. Charge needs to be in coulombs. Current needs to be in amps. Time needs to be in seconds. So current needs to be in amps, but in our question here, it's in milliamps. Milliamps means it's 1,000th of an amp. So what we need to do is, yep, that's right, good. We need to convert that by dividing it by 1,000. So first thing to do is 200 divided by 1,000, which gives us 0.2 amps. Now we can put it all into the equation, Q equals IT. So 0.2 times 15, which gives us an answer of 3 coulombs. Okay, next one. Yes, the website, it's got combined content in it, but for triple students need to know everything in this. So combined students need to know everything on this website, everything here, and that's it. Triple students will need to know everything on this website plus additional topics. I haven't put triple content on it. It's just doing this took me ages, it took me months, but I'm working on it. I don't know if it'll be ready before the exams. But yeah, if you're triple, learn everything here. So if you want to do paper 1, go up to topic 4. Learn everything there. If you're combined, just learn that. That's everything. So go through each topic one by one, read everything, go through the notes, then go through the questions, go through every question, blah, blah, blah. Check the mark scheme, check you got it right. And then check the spec points as well. Check that you know everything on it. Then mark it as complete. And then you got percentage there that tells you how much you've completed. And then just keep doing that until you get through up to topic 4. Once you've done that, you're ready for paper 1. If you're triple, you need to know all of this, plus you need to know a few extra topics as well. So yeah, has anyone tried out the website? What do you guys think? Those of you who've tried it out, is it useful? I've tried to make all the notes like really simplified, and I've tried to just teach you guys exactly what you need to know for your GCSEs. Nothing extra or nothing less. It's good. Yeah, good to hear. What's it called? flashrevisionlab.co.uk. Yeah, oh, that's good to hear, guys. Yeah, required practicals. If you want to go through all the required practicals, guys, literally just go to the search bar and search required practicals, and they'll come up, all the ones that you need to know. I'm working on triple, but honestly, it takes so long to make these notes. You can imagine I need to write all of this stuff. I need to draw the diagrams, which just take ages, and then I got to compile all the questions. It honestly takes so long, but I'm working on it. Next question. The manufacturer increases the current in the filament lamp from 200 milliamps, and now they've increased it to 320 milliamps. How many times greater than 200 milliamps is 320? What do you need to do there? Yeah, thank you for replying to that. Yeah, the website is got everything on it is combined, but triple need to know everything on the website plus a few extra topics. You don't need to divide by 1,000 here. You don't need to convert. It's just asking us how many times greater is 320 from 200. So what do you need to multiply 200 by to get 320? If this was 400, then you'll just say it's 2 times greater, isn't it? So we need a smaller number. Yeah, well done. Someone said it there. Well done, Izzy. 300, and you just need to do 320 divided by 200, which gives you 1.6. 1.6 times greater. Next question. The manufacturer tested lots of filament lamps. The current at which the lamp broke was this. What does this mean? The current at which the lamps broke was this. What does that symbol mean? It doesn't come up much, to be honest with you, but it came up here. This was a few years ago. I think this was 2020. Anyone know what that means? Yeah, uncertainty, plus or minus. Yeah, so basically, whenever you get this symbol, it means, so the current at which the filament lamp was, you would usually just say 320 milliamps. So that means if the current reaches 320 milliamps, it will break. But because they've got this extra bit here, that means it's not exactly 320 milliamps. It could be slightly more, it could be slightly less. And that's what this number tells us. So the maximum it could be is 60 plus 320. So 60 plus 320, that's 380. And the minimum it could be is 320 minus 60. So 320 minus 60, that's 260. So it's basically saying that this, for the lamp to break, it could be anything between these two numbers. Does that make sense? Or shall I explain that again? Let me know. So the answer would be anything between 260 and 380. Shall I explain that again, or does that make sense? Let me know, guys, in the chat. Because it doesn't come up much, so I wouldn't be surprised if you've never seen that symbol before. It's a plus or minus symbol. Yeah. Okay. Good. What paper is this? You can get this on my website. It's just loads of questions compiled together. Just go on the homepage of the website. It's this one here. It's the 24th of April. Sorry. Okay. I think we're on the last question. Yep. Last question. So we've got a boat here, sailing boat crossing an ocean, and there's a wind turbine on the boat. The wind turbine generates electricity to charge a battery. We've got a battery on the boat. Name one other renewable energy source that can be used on the boat to generate electricity. What do you guys think? It can't be any renewable source. It needs to be relevant to this boat. What do you guys think you could say? So let me get up all all the energy resources that you need to know. I think there's 8. So that's under energy is the last topic. Here we go. These are all the energy sources you need to be aware of. It's asked for renewables, so it has to be one of these ones. Which of these would be relevant for a boat? Solar, most people are saying solar. Yes, definitely solar would be good because you're out in the ocean, so you can get the sun. Wind, you can't say wind because they're already talking about wind turbines here. They've already got a wind turbine. They're saying one other renewable energy source, so you can't say that. Waves, yeah, some people are saying waves, that's fine. Hydroelectric, no, you can't say hydroelectric because for hydroelectric, you need a dam. You need a dam, which is like a big valley. Here, we've got all the information here on the notes of how it works. You can't put that on a boat, so that wouldn't work. Tides, yes, you do get tides in the sea, but when you're on a boat, you don't really feel the tide. The tide just gradually comes up in the day and then it gradually goes back down in the day. So it's not something that a boat will notice because the boat is just going to move up with the tide and move down with the tide. So you can't say tidal energy. Biofuel, that's another one you can say. So you could use biofuel and you could just burn that and that would work. You can't use geothermal. For geothermal, you need a volcanic area. Where's that? Here. Because you get energy from the Earth's interior. If you're on a boat, you can't really get that. So the answer that you would need to say is solar. Most people would hopefully just say solar for that one, but you can say wave or biofuel. Let's put solar. Okay, next question. The boat also has a generator that burns a fossil fuel. Okay, so that's a non-renewable energy source. The battery can be charged either by the wind turbine or the generator. So either by the wind or by the fossil fuel, by burning the fossil fuel. Give 2 reasons why this is useful. 2 reasons. I think it seems easy, it's just, but the wording needs to be very specific. What do you guys think? Let's see what people are saying. Because wind energy can be unreliable. Yes, that's true, but you got to be a bit more specific. You can't just say unreliable. What could happen? Why is it unreliable? Because this is no, it's not it's not always windy. Exactly. The wind can vary. The wind power, the power of the wind can vary. It does basically mean it's unreliable, but we just need to be a bit more specific there. There could be no wind, or you could say there could be less wind on some days, we'll say. And then a second reason. So we've explained what would happen if this ran out. If there was no wind, then what we can do is we can use the fossil fuel. Why is the wind turbine useful? So the fossil fuel is useful because on some days there'll be no wind. Why would the wind turbine be useful? Because it means that you don't need as much fossil fuel, right? Because if there was no wind turbine, you'd be using much more fossil fuel. You'll be burning much more fuel. So the fact that you also have a wind turbine means you can use less fossil fuels. You can say less fuels, or less fuel can be burned. If there is wind. So if there's a low amount of wind, we can use the fossil fuels. And if there is wind, you're basically using less fuel. So those are 2 reasons why it's good to have both. Hope that makes sense. Next question. Yep, people are answering already. Don't say more sustainable. That's a bit, again, that's a bit vague. Why is it more sustainable? Because what everyone else is saying is because it is a greenhouse gas. Yes. Don't say it creates pollution. That's a bit vague, okay? And what is it that causes it? Let's see what everyone's answers are. Releases greenhouse gas that gets trapped in the... What is the greenhouse gas that's being released? Everyone's saying greenhouse gases. What is it? There we go. 2 packs at it. Releases carbon dioxide. Let's actually state which gas it is. So it releases carbon dioxide. Which is a greenhouse gas, which increases global warming. Which is a greenhouse gas. Increases global warming. Okay, let's move on to the next one. Okay, we've got a few calculations here. Kinetic energy of the boat is 81 kilojoules. Mass of the boat is 8,000 kilograms. Calculate the speed of the boat. What do we need to do here? We need to use the equation for kinetic energy, right? So we did this earlier on one of the questions, and I said they were being really nice to you in the question because they actually rearranged the equation for you. This time, it hasn't been rearranged. So this is the equation we're trying to use. Kinetic energy equals half mv squared, but the question's asking for speed, isn't it? Yeah, it's calculating speed. So we need to make speed the subject of this formula. Kinetic energy. Let me just write EK because that's how it's usually written. EK is equal to half mv squared. So I'm just going to do it quicker this time because I did it last time already. So times both sides by 2. Divide both sides by n. That gives you v squared. And to get v, you square root both sides. So you'll get 2 times kinetic energy divided by mass. Let me know if any of these steps do not make sense. I'll explain it again. What else do you need to remember to do here? How many marks is this question? This question is 4 marks. Something else we need to do. What do you guys think? Those of you who have a calculator, try and work it out. Let me know what you get. Something else you need to remember to do, otherwise you'll lose a mark. Can anyone spot it? Yeah, there we go. The units here are in kilojoules. Let's look at the notes again. It needs to be in joules. In order to use this equation, you need to convert it to joules. So how do you turn it into joules? We've got to times it. Yep, we've got to times it. So you do 81 times 1,000 first to convert it. That's going to be 81,000. Well done. 81,000 joules. And now we can plug it all into this equation here. We've got the mass, we've got the kinetic energy, we've got the 2, we've got the square root sign. So let's do all of that. Let me know if you get the answer. 2 times 81,000 divided by the mass, which is 8,000 kilograms. Put that all into your calculator. Do not forget to square root it. I bet you so many people will lose marks because they'll forget to square root it. What are we getting? Everyone's saying 4.5, which is absolutely right. Right, does anyone have any questions about this one? Units is speed, so equation for speed is meters per second. We're nearly done. We've got one more question, guys. Next live It's going to be, so I'll be doing one on Sunday. That'll be biology and chemistry for anyone that wants more. And then I'll be doing another one on TikTok next Wednesday at the same time. I'll put that paper up soon. I haven't put that paper up, but the one for this week, I've already put up if you guys want to look at it. I think there's quite a few tickets left. Yeah, we've got 38. Yeah, we've got tickets left. Oh, if you guys want a discount, 20% discount on that, use this code, promo code, FRL20, if you want to join the live this Sunday. But yeah, the free ones on Wednesdays, this is just for people who just subscribe. So if you want 20% off, then yeah, just screenshot that and remember that. Great to hear. The website is very good. Yeah, I'm planning to add more exam boards. I'm planning to add triple science to it as well. It's just £5 for this, but the code will give you 20% off. So it'll make it £4. So I tried to make it as cheap as possible. It's just, yeah, making this website took a lot of resources, and I'm trying to make it better. I'm trying to help as many people as possible here. So I'm trying to add the triple content in and help other exam boards, and maybe even expand to like A-levels as well. It's just, it takes a lot of time to do all of that. So I tried to make everything as free as possible, but yeah. Okay. Let's do the last question then. As the boat passes over a wave, the GPE, the gravitational potential energy, you're welcome, of the boat increases by this much, 19,600 joules. The mass of the boat is 8,000 kilograms. Gravitational field strength is 9.8. Calculate the change in height of the center of mass of the boat. This is just here to confuse you, don't worry about that. Calculate the changing height of the boat as it passes over the wave. So we want the equation for gravitational potential energy. What's the equation that we've got for that? Anyone know? Gravitational potential energy, let me get that up. There we go. Thank you. MGH, gravitational potential energy is equal to mass times gravitational field strength times height. We want to work out height on the question. Is it height? Yeah, they want you to work out height. So we want to rearrange this equation. So gravitational potential energy is equal to mgh. Let's make height the subject. What we'll do is we'll divide both sides by mg. So divide that side by mg, divide this side by mg. So that would make it height is equal to gravitational potential energy divided by m times g. And now let's just double check we've got any conversions. Do we have any conversions to do? No, this is in joules, that's fine. No, this is in kilograms, that's fine. 9.8 newtons per kilogram, that's all fine. So we can just plug the numbers in now. Height is equal to 19,600 joules divided by 8,000. What did you guys get? What level is this? This is GCSE higher. GCSE physics higher, this question. People are finding it easy. What we get? Anyone got the answer there? Don't think it's 2.45. Oh, I forgot to do times 9.8. Sorry, I forgot to mention the G. Let's add that in. 8,000 times 9.8 gives you, yeah, you should be getting 0.25 meters. Well done, those of you getting that. Good. All right, guys. On that note, I think I'll leave it. So remember, this is the code, guys. It did get sold out on Sunday, so you probably do have a few days, but it did get sold out last week. This is the code to get 20% off. I will be back on next week. Same time, I'll be going through biology. I think I'll make this one a biology one as well. This is literally 2 days before the biology exam. I think I'll do some like the day before as well. So everything past May, I'm probably going to edit. I'm going to change the timetable according to when the exams are. So I'll try and do some lives just before exams, so you guys have like last minute revision. And yeah, where's this paper? You can download it right here. So go onto my website, flashrevisionlab.co.uk, go to 24th of April, paper download. And remember guys, you can watch all my past ones as well. You can download the papers and you can watch the replays. All the TikTok ones are on YouTube. I'll put them up on YouTube. I'll probably put this on YouTube as well for those of you who've missed it. So yeah, definitely check out my website guys, because that's completely free. I've been getting a lot of good feedback. It's really good to hear. And remember, for physics paper 1, go all the way up to end of topic 4. And I'll cover you. If you're combined, if you're triple, learn everything up to topic 4, so including topic 4, and then there's a few additional topics as well that you need to learn. Okay? Any other questions before I head off, guys? Why is my calculator giving me 24.01? Did you remember to square root it at the end? No, that can't be it. Put this in brackets. I think this is what you did. I think you forgot to, I think you might have done 19,600 divided by 8,000 and then times it by 9.8. So put this bottom bit in brackets, or do this bit first and then do 19,600 divided by answer. Yeah, that's it. I'll post this, this whole live I'll post on YouTube tomorrow. I'll try and do it tomorrow.